Time, the most invisible force in the universe, yet perhaps the one that defines us the most. We wake each day aware of its steady ticking. It's there when we feel the rush of fleeting moments, the yearning to hold on to what's gone, and the excitement of what's yet to come. But have we ever truly questioned it? Have we ever considered that time, this invisible river, might not always flow in one direction? Could we step outside its current, bend its flow, or perhaps even traverse its currents? To us, time is linear, a one-way street. But what if this belief is a simplification? What if, instead of flowing straight ahead, time is more like a vast, intricate fabric woven into the very structure of reality, each thread representing a different moment, yet all connected, all interdependent? Could we, in the future, learn to manipulate these threads, alter the past, glimpse into the future, or even walk across the present in ways we never thought possible? Over a century ago, the genius of Albert Einstein gave us a new lens through which to view the universe. With his theories of special relativity and general relativity, he shattered our understanding of time. He revealed that time is not constant, not universal. It is, in fact, part of the fabric of space itself, a dynamic, flexible concept intertwined with gravity and the shape of the cosmos. According to Einstein, time is not just a number that ticks away, it is a dimension that can be stretched, bent, and altered depending on the circumstances. Imagine, for a moment, that you are in a spaceship traveling near the speed of light, an unimaginable velocity in our everyday world. According to Einstein's special relativity, as you near the speed of light, time would start to slow down for you. For someone watching from Earth, you would appear to move in slow motion, as if you were caught in a moment that never seemed to end. But to you, on board that spaceship, time would pass as it always does. Your heart would still beat, your clock would still tick. For you, the journey might feel like only a few hours or days. But for those on Earth, years, decades, could pass in the blink of an eye. This is the twin paradox, one of the most profound implications of time dilation. Imagine you are one twin, and your sibling travels at near light speeds. When they return from their journey, they will have aged far less than you. You, who stayed on Earth, will have lived through decades while your twin has experienced only a few moments. It's as though you've traveled to the future without ever meaning to. The twin who ventured into space has been in time's embrace, but time itself has been kind to them. For them, the universe has moved forward in slow motion, while for you, it has marched on relentlessly. But what of the past? Could we break the fabric of time and travel backward? Could we peer into the past and change what has already been? Here, in the very heart of the universe, we encounter the black hole, the ultimate cosmic enigma, a region of space so dense, so intense in gravity, that it bends time and space in impossible ways. As you approach the event horizon, the point of no return, time begins to warp in unimaginable ways. To an outside observer, it appears as though time comes to a halt with no way of escaping. And yet, if you were to fall into a black hole, you might experience time in an entirely different way, almost as though time itself had become a tangible substance, something you could pass through and stretch, alter, or even lose control of. Yet, in this abyss of unknowns, there exists another potential, the wormhole, a theoretical structure in the fabric of space-time that could connect two distant points in space, and possibly two distant points in time. Picture it as a shortcut, a bridge between the future and the past. A wormhole could, in theory, allow a person or an object to travel back in time, to step outside the flow of events, to visit a moment that already exists, or even to change it. But creating or stabilizing a wormhole would require an entirely new kind of matter, exotic matter, with negative energy. And that's where we hit a problem. We've never found this exotic matter, and even if it exists, we have no idea how to harness it to create a stable passage through the cosmos. Is this a dream too far out of reach? Or are we closer to this leap than we dare imagine? But with the potential to travel through time comes a dangerous question. What happens if we change the past? Could we alter history? The grandfather paradox asks, if you traveled back in time and prevented your grandfather from meeting your grandmother, how could you ever have been born to make that change in the first place? If you were never born, you could not have traveled back, and therefore, the past would remain unchanged. Does this create a closed loop where history is constantly folding upon itself, where one action erases the possibility of the other? Or does the universe find a way to correct itself, to preserve a constant timeline, no matter how much we try to tamper with it? Some theories suggest that parallel timelines could exist, alternate versions of reality that spring into existence every time a decision is made. If time travel is possible, could it be that by changing the past, we create a new branching timeline? Could we shift from one reality to another with each action we take in the past? And if that's true, could we live in a universe where an infinite number of possible realities exist, each diverging from a singular point of origin, creating an ever-expanding web of choices, possibilities, and consequences? Is it possible to build a machine that could navigate these possibilities? To harness the very forces of space-time, bending them to our will and altering the flow of time itself? Theoretically, the equations for time travel exist, but we are nowhere near the technology that would be required. We may one day discover how to manipulate space-time, just as Einstein theorized, but the energy demands would be tremendous. Perhaps we will discover new forms of matter, new ways to stabilize wormholes, new methods to navigate through black holes. Or perhaps we'll find that time travel is simply too great a leap for humanity, something beyond our grasp for reasons we cannot yet understand. Time is the most fundamental of forces, the most mysterious. It is both the framework and the subject of our existence. And as we continue to explore the deepest reaches of the universe, we find that time, in all its grandeur, is far from what we imagined. It is not a constant, not a ruler that we simply follow, but a force that may yet surprise us. Can we travel through it? Can we manipulate it? Perhaps one day, we will find the answers. But until then, we are left with this. Time is not just something we experience. It is something we are a part of, something we are yet to fully understand, and perhaps something that we are destined to unlock. The journey through time is not just a dream. It is the final frontier, waiting to be explored.